Alright students, in this video we are going to discuss one of the question of model paper, and this question is from the chapter Trigonometry, chapter number 15. This question is not included in any of your exercises, but yes, it is present in your model paper and it has been previously asked in many other past papers as well. So this is trigonometric ratios of angles of 45 degree. We are going to find the values of different trigonometric ratios of a right angle triangle which has an one angle of 45 degree. So basically there are two types of right angle triangles. One is 45 45 90 degree triangle where the three angles are 45 45 degree and a 90 degree, and another is a 30 60 90 degree right angle triangle where the three angles are 30 degree 60 degree and 90 degree. So here we are going to discuss values of trigonometric ratios where we are considering an angle of a right angle triangle as 45 degree. So over here we have angle B as 45 degree. Since we know that the acute angle of a right angle triangle are complementary, we can say that if angle B is 45 degree, then measure of angle A will be 45 degree, which is 90 minus 45, and that is why angle A will also be 45 degree. How did I conclude that? This is because we know that the complementary angle of a right angle triangle, the acute angle of a right angle triangle are complementary. Okay, now we have that the angle B is 45 degree and angle A is also 45 degree. Okay, that means they are same. And we know that in a triangle, when the two angles are same, their opposite sides are also same. When two angles of a triangle are congruent, their opposite sides are also congruent. Now, the opposite side for angle A is the side BC, which we can name as which we have named as A, and the opposite side of angle B is AC, which we have named as B. So we have also named these three sides as A, B and C, and I have written here A is equal to B because these sides are the opposite sides of two congruent angles. Angle B and angle A are congruent because they have 45 degrees, and that is why this side A is equal to side B. So these two sides AC and BC, they are congruent, they are equal, and that is why I have written as A is equals to B. Now we will apply a Pythagoras theorem on this right angle triangle. We are going to apply Pythagoras theorem on the right angle triangle because we want to find the trigonometric values of this particular triangle. Okay, so let us see what do we get when we apply the Pythagoras theorem. We can say that c square is equals to a square plus b square, which is the hypotenuse square, is equals to the sum of the squares of the two sides. Here I can say that since a is equals to b, I can write a square as b square. Okay, since a is equals to b, how is a is equals to b? We have seen it in the previous slide. So I have just written b in place of a. B square plus b square is equals to 2b square. So what do I get over here? C square is equals to 2b square. Now removing the squares from both the sides, taking the square root on both the sides, what do we get? We get C is equals to root 2b. So basically we have find the relation between the sides of the triangle. One relation is A is equals to B, which we saw in the previous slide, and this is the second relation, C is equals to root 2b. Okay, now we are going to find the trigonometric values. Since we know that sine of any angle, we are considering sine of 45 degree, that is the sine of angle B over here. As we know that sine theta is equals to perpendicular upon hypotenuse. Okay, we know that sine of theta is equal to perpendicular upon hypotenuse. Sine 45 will also be perpendicular upon hypotenuse. Here the perpendicular is side AC and the hypotenuse is side AB, and that is why sine of 45, sine of this angle B 45 will be B upon C. Okay, sine 45 will be perpendicular upon base, which will be B upon C. That is what is given over here. Sine 45 is B upon C. We have written over here B upon C. Now we know that C is also equals to root 2b, so instead of C we have written root 2b. Now I can cancel this B and b from the numerator and the denominator. When you cancel the b from the numerator and the denominator, you get 1 upon root 2, and this is the value of sine 45 degree, 1 upon root 2. Similarly, when we try to find the next trigonometric ratio, which is cos 45 for the same angle of 45 degree, we know that cos is base upon hypotenuse. Here the base is side A upon C. Again we know that A is equals to B. We know that we have seen it from the previous slide, and root C is equals to root 2b. So I have substituted both the values over here. Again I can cancel b from the numerator and the denominator, and I get C cos 45 is equals to 1 upon root 2. Next is tan 45. Tan 45 is perpendicular upon base, which is b upon a, and b is equals to a, so I have written a upon a over here. Okay, now cancelling this a and a, I get 1. Okay, when we cancel a in the numerator and denominator, what is left? 1 is left. So tan 45 is equals to 1. Now moving on to the other trigonometric ratios, they are the reverse of the previous trigonometric ratios. Like cot 45 is 1 upon tan 45, which will be equals to 1 because tan 45 is also equal to 1. So cot 45 will be equal to 1. Similarly, sec 45 is equals to 1 upon cos 45. Since cos 45 is 1 upon root 2, since cos 45 is 1 upon root 2, sec 45 will be root 2. Okay, the reverse of cos 45. And again, cosec 45 is equals to 1 upon sine 45, and that is why sine 45 is 1 upon root 2, so cosec 45 will be root 2. So in these 3 slides we have find all the trigonometric ratios for the angle of 45 degree in a right angle triangle. Now the next is finding the same values of the trigonometric ratios for an angle of 30 degree. So when you have a triangle of 30 degree, it's like, see, if you consider angle B as 30 degree over here, what will be your angle A? Angle A will be 90 minus 30 degree, which is equals to 60 degree, and that is why your C will be changed over here. Okay, when in a right angle triangle of 30 degree angle, okay, in a right angle triangle where you have a 30 degree angle, always remember that your hypotenuse will be twice the opposite side. Okay, so similarly the hypotenuse C is equals to 2b over here. This one thing which we will have to remember in this particular derivation. Okay, that is hypotenuse is 2 times that of the perpendicular side. Okay, is twice the perpendicular side, so you will have to remember here the hypotenuse C is equals to 2b. Why? Because it is a 30 degree right angle triangle. Okay, now I want you to apply the Pythagoras theorem on this triangle as well and find all the values of the trigonometric ratios similarly as we have done for the angle of 45 degree. So these are the 2 derivations which you have to practice and learn, because you will have question on them. The question will be to find the values of all the trigonometric ratios for angle of 30 degree or for angle of 45 degree. You will have any question on any one of them. Okay, so keep practicing, and inshallah we'll discuss some more important questions from the model paper in the next video. Till then, take care and Allah Hafiz.